Ruby is a dynamic, reflective, object-oriented, general-purpose programming language. It was designed and developed in the mid-1990s by Yukihiro Matsumoto in Japan. According to its authors, Ruby was influenced by Perl, Smalltalk, Eiffel, Ada, and Lisp. It supports multiple programming paradigms, including functional, object-oriented, and imperative. It also has a dynamic type system and automatic memory management. History. Early concept. Ruby was conceived on February 24, 1993. In a 1999 post to the Ruby Talk mailing list, Ruby author Yukihiro Matsumoto described some of his early ideas about the language. I was talking with my colleague about the possibility of an object-oriented scripting language. I knew Perl, but I didn't like it really, because it had the smell of a toy language. The object-oriented language seemed very promising. I knew Python then. But I didn't like it, because I didn't think it was a true object-oriented language. EA features appeared to be add-on to the language. As a language maniac and OO fan for 15 years, I really wanted a genuine object-oriented, easy-to-use scripting language. I looked for but couldn't find one. So I decided to make it. Matsumoto describes the design of Ruby as being like a simple Lisp language at its core, with an object system like that of Smalltalk, blocks inspired by higher-order functions, and practical utility like that of Perl. The name Ruby originated during an online chat session between Matsumoto and Keiji Ishizuka on February 24, 1993, before any code had been written for the language. Initially two names were proposed, Coral, and Ruby. Matsumoto chose the latter in a later email to Ishizuka. Matsumoto later noted a factor in choosing the name Ruby. It was the birthstone of one of his colleagues. First publication. The first public release of Ruby 0.95 was announced on Japanese domestic news groups on December 21, 1995. Subsequently 3 more versions of Ruby were released in 2 days. The release coincided with the launch of the Japanese language Ruby List mailing list, which was the first mailing list for the new language. Already present at this stage of development were many of the features familiar in later releases of Ruby, including object-oriented design, classes with inheritance, mixins, iterators, closures, exception handling and garbage collection. Early releases. Following the release of Ruby 0.95 in 1995, several stable versions of Ruby were released in the following years: Ruby 1.0 December 25, 1996, Ruby 1.2 December 1998, Ruby 1.4 August 1999, Ruby 1.6 September 2000. In 1997, the first article about Ruby was published on the web. In the same year, Matsumoto was hired by NetLab JP to work on Ruby as a full-time developer. In 1998, the Ruby Application Archive was launched by Matsumoto, along with a simple English language homepage for Ruby. In 1999, the first English language mailing list Ruby Talk began, which signaled a growing interest in the language outside of Japan. In this same year, Matsumoto and Keiji Ishizuka wrote the first book on Ruby, the object-oriented scripting language Ruby, which was published in Japan in October 1999. It would be followed in the early 2000s by around 20 books on Ruby published in Japanese. By 2000, Ruby was more popular than Python in Japan. In September 2000, the first English language book Programming Ruby was printed, which was later freely released to the public, further widening the adoption of Ruby amongst English speakers. In early 2002, the English language Ruby Talk mailing list was receiving more messages than the Japanese language Ruby list, demonstrating Ruby's increasing popularity in the English-speaking world. Ruby 1.8 Ruby 1.8 was initially released in August 2003, was stable for a long time, and was retired June 2013. Although deprecated, there is still code based on it. Ruby 1.8 is incompatible with Ruby 1.9. Ruby 1.8 has been the subject of several industry standards. The language specifications for Ruby were developed by the Open Standards Promotion Center of the Information Technology Promotion Agency for submission to the Japanese Industrial Standards Committee and then to the International Organization for Standardization. It was accepted as a Japanese industrial standard in 2011 and an international standard in 2012. Around 2005, interest in the Ruby language surged in tandem with Ruby on Rails, a popular web application framework written in Ruby. Rails is frequently credited with making Ruby famous. Ruby 1.9 Ruby 1.9 was released in December 2007. Effective with Ruby 1.9.3, released October 31, 2011, Ruby switched from being dual-licensed under the Ruby license and the GPL to being dual-licensed under the Ruby license and the two-clause BSD license. Adoption of 1.9 was slowed by changes from 1.8 which required many popular third-party gems to be rewritten. Ruby 1.9 introduces many significant changes over the 1.8 series. Examples: block local variables, an additional lambda syntax, f equals a, b, puts a plus b, per string character encodings are supported, new socket API, require relative import security. Ruby 2.0 Ruby 2.0 added several new features, including method keyword arguments, a new method, module prepend, for extending a class, a new literal for creating an array of symbols, new API for the lazy evaluation of enumerables, and a new convention of using /h to convert objects to hashes. Ruby 2.0 is intended to be fully backward compatible with Ruby 1.9.3. As of the official 2.0.0 release on February 24, 2013, there were only 5 known incompatibilities. Ruby 2.1 Ruby 2.1.0 was released on Christmas Day in 2013. The release includes speed-ups, bug fixes, and library updates. Starting with 2.1.0, Ruby is using semantic versioning. Philosophy. Matsumoto has said that Ruby is designed for programmer productivity and fun, following the principles of good user interface design. At a Google Tech Talk in 2008, Matsumoto further stated, "I hope to see Ruby help every programmer in the world to be productive, and to enjoy programming, and to be happy. That is the primary purpose of Ruby language." He stresses that systems design needs to emphasize human, rather than computer, needs. Often people, especially computer engineers, focus on the machines. They think, by doing this, the machine will run faster. By doing this, the machine will run more effectively. By doing this, the machine will something. They are focusing on machines. But in fact we need to focus on humans, on how humans care about doing programming or operating the application of the machines. We are the masters. They are the slaves. Ruby is said to follow the principle of least astonishment, meaning that the language should behave in such a way as to minimize confusion for experienced users. Matsumoto has said his primary design goal was to make a language which he himself enjoyed using, by minimizing programmer work and possible confusion. He has said that he had not applied the principle of least astonishment to the design of Ruby, but nevertheless the phrase has come to be closely associated with the Ruby programming language. The phrase has itself been a source of surprise, as novice users may take it to mean that Ruby's behaviors try to closely match behaviors familiar from other languages. In a May 2005 discussion on the news group Complang Ruby, Matsumoto attempted to distance Ruby from POLA, explaining that because any design choice will be surprising to someone, he uses a personal standard in evaluating surprise. If that personal standard remains consistent, there would be few surprises for those familiar with the standard. Matsumoto defined it this way in an interview. Everyone has an individual background. Someone may come from Python, someone else may come from Perl, and they may be surprised by different aspects of the language. Then they come up to me and say, "I was surprised by this feature of the language." So Ruby violates the principle of least surprise. Wait. The principle of least surprise is not for you only. The principle of least surprise means principle of least my surprise. and it means the principle of least surprise after you learn Ruby very well. For example, I was a C++ programmer before I started designing Ruby. I programmed in C++ exclusively for 2 or 3 years. And after 2 years of C++ programming, it still surprises me. Features: thoroughly object-oriented with inheritance, mixins and metaclasses, dynamic typing and duck typing, everything is an expression and everything is executed imperatively, succinct and flexible syntax that minimizes syntactic noise and serves as a foundation for domain-specific languages, dynamic reflection and alteration of objects to facilitate metaprogramming, lexical closures, iterators and generators, with a unique block syntax, literal notation for arrays, hashes, regular expressions and symbols, embedding code in strings, default arguments, 4 levels of variable scope denoted by sigils or the lack thereof, garbage collection, first-class continuations, strict Boolean coercion rules, exception handling, operator overloading, built-in support for rational numbers, complex numbers and arbitrary precision arithmetic, custom dispatch behavior, native threads and cooperative fibers, initial support for Unicode and multiple character encodings, native plugin API in C, interactive Ruby shell, centralized package management through Ruby gems, implemented on all major platforms, large standard library, including modules for YAML, JSON, XML, CGI, OpenSSL, HTTP, FTP, RSS, curses, zlib, and TK, semantics. Ruby is object-oriented, every value is an object, including classes and instances of types that many other languages designate as primitives. Variables always hold references to objects. Every function is a method and methods are always called on an object. Methods defined at the top-level scope become members of the object class. Since this class is an ancestor of every other class, such methods can be called on any object. They are also visible in all scopes, effectively serving as global procedures. Ruby supports inheritance with dynamic dispatch, mixins and singleton methods. Though Ruby does not support multiple inheritance, classes can import modules as mixins. Ruby has been described as a multi-paradigm programming language. It allows procedural programming, with object orientation or functional programming. It has support for introspection, reflection and metaprogramming, as well as support for interpreter-based threads. Ruby features dynamic typing, and supports parametric polymorphism. According to the Ruby FAQ, if you like Perl, you will like Ruby and be right at home with its syntax. If you like Smalltalk, you will like Ruby and be right at home with its semantics. If you like Python, you may or may not be put off by the huge difference in design philosophy between Python and Ruby Perl. Syntax: the syntax of Ruby is broadly similar to that of Perl and Python. Class and method definitions are signaled by keywords. In contrast to Perl, variables are not obligatorily prefixed with a sigil. When used, the sigil changes the semantics of scope of the variable. One difference from C and Perl is that keywords are typically used to define logical code blocks, without braces. For practical purposes there is no distinction between expressions and statements. Line breaks are significant and taken as the end of a statement. A semicolon may be equivalently used. Unlike Python, indentation is not significant. One of the differences of Ruby compared to Python and Perl is that Ruby keeps all of its instance variables completely private to the class and only exposes them through accessor methods. Unlike the getter and setter methods of other languages like C++ or Java, accessor methods in Ruby can be created with a single line of code via metaprogramming. However, accessor methods can also be created in the traditional fashion of C++ and Java. As invocation of these methods does not require the use of parentheses, it is trivial to change an instance variable into a full function, without modifying a single line of code or having to do any refactoring, achieving similar functionality to C and VB.NET property members. Python's property descriptors are similar, but come with a trade-off in the development process. If one begins in Python by using a publicly exposed instance variable, and later changes the implementation to use a private instance variable exposed through a property descriptor, code internal to the class may need to be adjusted to use a private variable rather than the public property. Repositories unregistered trademark S design forces all instance variables to be private, but also provides a simple way to declare set and get methods. This is in keeping with the idea that in Ruby, one never directly accesses the internal members of a class from outside of it. Rather, one passes a message to the class and receives a response. See the examples section below for samples of code demonstrating Ruby syntax. Differences from other languages. Some features which differ notably from languages such as C or Perl. The language syntax is sensitive to the capitalization of identifiers, in all cases treating capitalized variables as constants. Class and module names are constants and refer to objects derived from class and module. The sigils $ and $. Do not indicate variable data type as in Perl, but rather function as scope resolution operators. Floating point literals must have digits on both sides of the decimal point, neither 0.5 nor 2 are valid floating point literals, but 0.5 and 2.0 are. In Ruby, integer literals are objects that can have methods applied to them, so requiring a digit after a decimal point helps to clarify whether 1e5 should be passed analogously to 1 to f4 as the exponential format floating literal 1.0e5. The reason for requiring a digit before the decimal point is less clear. It might relate either to method invocation again, or perhaps to the AND operators, for example in the fragment 0.1. 3. Boolean non-Boolean data types are permitted in Boolean contexts, but their mapping to Boolean values differs markedly from some other languages. 0 and empty all evaluate to true, thus changing the meaning of some common idioms in related or similar languages such as Lisp, Perl and Python. A consequence of this rule is that Ruby methods by convention for example, regular expression searches return numbers, strings, lists, or other non-false values on success, but nil on failure. Versions prior to 1.9 use plain integers to represent single characters, much like C. This may cause surprises when slicing strings. ABC, 0, yields 97. To obtain a use ABC, 0, 1, or ABC, 0, CHR. The notation statement until expression does not run the statement if the expression is already true. In C. This is because statement until expression is actually syntactic sugar over until expression. Statement. End, the equivalent of which in C++ is while statement. Just a statement if expression is equivalent to if statement. However, the notation begin statement end until expression in Ruby will in fact run the statement once even if the expression is already true, acting similar to the do-while of other languages. Because constants are references to objects, changing what a constant refers to generates a warning, but modifying the object itself does not. For example, greeting world. If greeting hello does not generate an error or warning. This is similar to final variables in Java or a const pointer to a non-const object in C++, but Ruby provides the functionality to freeze an object, unlike Java. Some features which differ notably from other languages, the usual operators for conditional expressions, and, or, do not follow the normal rules of precedence, and does not bind tighter than or. Ruby also has expression operators and that work as expected. A list of so-called gotchas may be found in Hal Fulton's book The Ruby Way, 2nd ed., section 1.5. A similar list in the first edition pertained to an older version of Ruby, some problems of which have been fixed in the meantime. For example, retry now works with while, until, and for, as well as with iterators. Interaction. The Ruby official distribution also includes IB, an interactive command line interpreter which can be used to test code quickly. The following code fragment represents a sample session using IB. Examples. The following examples can be run in a Ruby shell such as interactive Ruby shell, or saved in a file and run from the command line by typing Ruby file name. Classic Hello World example. Some basic Ruby code. Conversions. Strings, There are a variety of ways to define strings in Ruby. The following assignments are equivalent. Strings support variable interpolation. The following assignments are equivalent and produce raw strings. Collections, constructing and using an array. Constructing and using an associative array. Blocks and iterators, the two syntaxes for creating a code block. A code block can be passed to a method as an optional block argument. Many built-in methods have such arguments. Parameter passing a block to be a closure. Creating an anonymous function. Returning closures from a method. Yielding the flow of program control to a block which was provided at calling time. Iterating over enumerations and arrays using blocks. A method such as inject can accept both a parameter and a block. The inject method iterates over each member of a list, performing some function on it while retaining an aggregate. This is analogous to the FOLDL function in functional programming languages. For example, on the first pass, the block receives 10 as sum, and 1 as element. This returns 11, which then becomes sum on the next pass. It is added to 3 to get 14, which is then added to 5 on the third pass, to finally return 19. Using an enumeration and a block to square the numbers 1 to 10. Or invoke a method on each item. Classes, the following code defines a class named person. In addition to initialize, the usual constructor to create new objects, it has two methods, one to override the equals comparison operator and the other to override the toS method. Here, AttReader is an example of metaprogramming in Ruby. AttRaccessor defines getter and setter methods of instance variables, but AttReader only getter methods. The last evaluated statement in a method is its return value, allowing the omission of an explicit return statement. The preceding code prints three names in reverse age order. Person is a constant and is a reference to a class object. Open classes, in Ruby, classes are never closed, methods can always be added to an existing class. This applies to all classes, including the standard, built-in classes. All that is needed to do is open up a class definition for an existing class, and the new contents specified will be added to the existing contents. A simple example of adding a new method to the standard library's time class. Adding methods to previously defined classes is often called monkey patching. However, if performed recklessly, this practice can lead to collisions of behavior and subsequent unexpected results, and problems with code scalability. Exceptions. An exception is raised with a raise call. An optional message can be added to the exception. Exceptions can also be specified by the programmer. Alternatively, an exception instance can be passed to the raise method. This last construct is useful when a custom exception class featuring a constructor which takes more than one argument needs to be raised. Exceptions are handled by the rescue clause. Such a clause can catch exceptions which inherit from standard error. Other flow control keywords that can be used when handling exceptions are else and ensure. It is a common mistake to attempt to catch all exceptions with a simple rescue clause. To catch all exceptions one must write or catch particular exceptions. It is also possible to specify that the exception object be made available to the handler clause. Alternatively, the most recent exception is stored in the magic global $. Several exceptions can also be caught. Metaprogramming. Ruby code can programmatically modify, at runtime, aspects of its own structure that would be fixed in more rigid languages, such as class and method definitions. This sort of metaprogramming can be used to write more concise code and effectively extend the language. For example, the following Ruby code generates new methods for the built-in string class, based on a list of colors. The methods wrap the contents of the string with an HTML tag styled with the respective color. The generated methods could then be used like this. To implement the equivalent in many other languages, the programmer would have to write each method separately. Some other possible uses for Ruby metaprogramming include intercepting and modifying method calls, implementing new inheritance models, dynamically generating classes from parameters, automatic object serialization, interactive help and debugging. More examples. More sample Ruby code is available as algorithms in the following articles: exponentiating by squaring, Trapp-Pardo-Knuth algorithm, implementations. Matz's Ruby interpreter, the official Ruby interpreter often referred to as the Matz's Ruby interpreter or MRI. This implementation is written in C and uses its own Ruby-specific virtual machine. The standardized and retired Ruby 1.8 implementation was written in C, as a single-pass interpreted language. Starting with Ruby 1.9, and continuing with Ruby 2.0 and 2.1, the official Ruby interpreter has been YARV, and this implementation has superseded the slower virtual machine used in previous releases of MRI. Alternate implementations. As of 2010, there are a number of alternative implementations of Ruby, including JRuby, Robinius, Maglev, Iron Ruby, MacRuby, Ruby, Hot Ruby, Topaz and Opal. Each takes a different approach, with Iron Ruby, JRuby, MacRuby and Robinius providing just-in-time compilation and MacRuby and Ruby also providing ahead-of-time compilation. Ruby 1.9 has two major alternate implementations, JRuby, a Java implementation that runs on the Java Virtual Machine, Robinius, a C++ bytecode virtual machine that uses LLVM to compile to machine code at runtime. The bytecode compiler and most core classes are written in pure Ruby. Other Ruby implementations include, Maglev, a Smalltalk implementation that runs on GemTalk Systems Gemstone SVM, a GSS, or Ruby Game Scripting System, an implementation that is used by the RPG Maker series of software for game design and modification of the RPG Maker engine. Other now-defunct Ruby implementations were, MacRuby, an OS X implementation on the Objective-C runtime, Cardinal, an implementation for the Parrot virtual machine, Iron Ruby, an implementation on the .NET framework. Ruby can also run on Embedded System by Ruby, developing in GitHub. The maturity of Ruby implementations tends to be measured by their ability to run the Ruby on Rails framework, because it is complex to implement and uses many Ruby-specific features. The point when a particular implementation achieves this goal is called the Rails singularity. The reference implementation, JRuby, and Robinius are all able to run Rails unmodified in a production environment. Iron Ruby is starting to be able to run Rails test cases, but is still far from being production-ready. Platform support. Matsumoto originally did Ruby development on the 4.3 Bahamian dollars-based Sony Muse OS 3X, but later migrated his work to Sun OS 4X, and finally to Linux. By 1999, Ruby was known to work across many different operating systems, including Muse OS, Sun OS, AIX, SVR4, Solaris, NEC-UX, NeXTSTEP, BSD, Linux, Mac OS, DOS, Windows, and BOS. Modern Ruby versions and implementations are available on many operating systems, such as Linux, BSD, Solaris, AIX, Mac OS X, Windows, Windows Phone, Windows CE, Symbian OS, BOS, and IBM I. Repositories and Libraries. Ruby Gems is Ruby's package manager. A Ruby package is called a gem, and can easily be installed via the command line. There are over 70,000 Ruby gems hosted on rubygems.org. Many new and existing Ruby libraries are hosted on GitHub, a service that offers version control repository hosting for Git. See also: Comparison of programming languages, Wise Guide to Ruby, an online Ruby textbook in graphic novel format, Metasploit Project, the world's largest Ruby project, with over 700,000 lines of code, XUBY. References. Further reading. External links, official website, official Ruby documentation, Ruby User Guide by Yukihiro Matsumoto, the creator of Ruby, Ruby from other languages, Ruby Forum, gateway to the Ruby Talk mailing list, Try Ruby. web-based Ruby REPL, Ruby Draft Specification, September 2010, Ruby at DMOZ.